of all, if we look, it does give us the equation, so it's an x to the fourth. What should the end behavior be for x to the fourth? Up, which is what this is, so we're good there. We notice this hits the x-axis at -5. So what would I have to have in my polynomial so that -5 makes it 0? You would have to have x plus 5. Is everybody with me?
Yes.
Because if I put in a -5 plus 5 equals 0. Okay? Now, when I look at this graph, it hit at -5 and bounced. What did I tell you causes a graph to bounce? Even multiplicity, so this needs a square on it. All right, where's the next place it hits the x-axis?
0.
0. So x minus 0 is the same as just x. So I just need a plain x. I'm going to put that in front. The next place it hits the x-axis is 3. So what would I have to have in here?
X minus 3. But it goes right through, so you don't
It goes
need that.
through, so we don't need the square. So that is my polynomial, just from the graph itself. Now look at D. So question 20 is doing the same thing with D. What's this in behavior? You can put it just on the end of your homework. What's this in behavior? Up, down. What does that tell you?
Oh, we are supposed to be putting this?
Yeah, just put it on the end.
Okay.
Yeah. We know it's an odd degree because the ends are going opposite direction, but they're flipped from normal, so it has to be a negative. All right, first place we hit is at -6, so what has to go in here? It went through, so we don't need anything there. The next place it hits is -1, so we need +1, and it would get a square because it bounces. Next place we hit is
I can't see that.
it does hit at 5 and also at 3. So if it hits at 3, it gets, if it hits at 5, and both of those just went through, so neither of those get a square. So that's just using the graph to factor our polynomial. All right, let's grade our homework.
Look at those little simple
Okay.
words.
Hang on to that one second. They're gonna have to.
Did you accept that? I kind of like wrote that uneven.
So is it 18 points?
Yes, 18 points. All right, number 1, in behavior, down, up. Number 2, up, down. Number 3, down, down. Number 4, up, up. Number 5, up, down. 6, up, up. 7, down, up. 8, down, down. Number 9 is 4. 10 is 1. 11 is 2. 12 is 3. 13, A. 14, B. 15, 1. 16, C. 17, both B and D work. So there's 2 answers. If you only had 1, take off a half. And 18 is B. So 18 points. On number 17, the reason there were 2, it asked which ones could not be a cube. So B has the wrong end behavior. D doesn't work because it has 4 zeros, so it has to be at least degree 4. There were too many x-intercepts. Any questions on that? No. Then just pull that up and get out notes. Do notes in our notebook today. We're going to start 4.2. I won't get all the way through it. And then we are going to do Math Excel.
Theory or something.
Alright, so there's a couple main things that we're talking about today. The first one is kind of new. So maybe you saw it in Algebra 2, but I can't guarantee that. It's the intermediate value theorem. Does that sound familiar at all?
Yeah.
No.
What you said?
Intermediate value theorem?
Not at all.
But
Okay.
I may or may not have been listening if she said it.
Okay, so here's the gist of it. So the intermediate value theorem says, in a polynomial, P of x, if P of A and P of B have different signs, a zero exists between A and B. Okay, so what that means, we know that in a polynomial, the graph is always a nice smooth curve. So if P of A and P of B, so A and B are just x values. It's saying if those have different signs, so one of them is positive and one of them is negative. Okay, if you have a nice smooth curve, the only way to get from a positive to a negative is by crossing 0. So the only way I could get down here is by hitting 0. So if one is positive and one is negative, then there's somewhere on that interval where your graph is equal to 0. Does that seem reasonable to everybody?
Absolutely not.
Got to be difficult, don't you? So, a lot of times I will ask you to use this to prove that there's a 0 between two specific numbers. So we'll look at an example of that. I'm going to show that this polynomial has a 0 between 2 and 3. So there's some number between 2 and 3 that I can plug in that would make this whole thing equal 0. So what we're going to do is plug each of these into the function. So I have to actually figure out what P of 2 and P of 3 are. So if I put a 2 in, grab a calculator, okay, so if you put in 2, you get out -1. If we put in a 3, we get 7. So, if you think about what that means on the graph, when x is 2, y is -1. When x is 3, y is 7. So does it cross 0 in between those? It has to. The only way to get from a negative to a positive is by hitting 0. So there's a sign change, So there's a 0.
Wait, so this means that you're not wanting us to draw a graph, right?
No.
Okay.
All right, if they're the same sign, does that tell me anything? If I plugged in, I got +1 and +7?
No.
No. It doesn't mean there's not a 0. For all I know, it dipped down real fast and already came back up. But I can't prove there is or isn't if they're the same. So this only works if they're different. Let's find it using our graphing calculator. I'm going to show you some of these tricks when we have the opportunity. So go to your graph, the y equals, and type in this function. So x cubed minus 2x squared minus x plus 1. And then graph it. So looking at the graph, does it look like somewhere between 2 and 3 it equals 0? Yes. We can find that exactly by going to second trace. This takes us into our calculate menu, all the things our calculator can find. What am I looking for? A 0, number 2. Okay, ask this question. A polynomial goes on forever, so your calculator can't search the whole thing. It'll bog it down and it'll shut down on you. It'll freeze. So we have to tell it, start looking here and stop here. So a left bound, that just means somewhere to the left of this point. So you can use your left and right arrows. You just need to be to the left of that point we're looking for. And hit enter. And notice it draws this little line. It tells me I'm going to start here. Right bound, so you just go past your point. Doesn't really matter how far, you just have to be past it. So I'm telling my calculator, only look between those two. And then it says guess. If you just hit enter, you should be close enough that it'll work.
Did you get 2.2?
Yeah.
Yep.
Okay.
2.2469. So let's just say 2.25. Approximately.
Ooh, is that necessary? Okay.
It's a swing one. Paul.
Is that okay with everybody?
Show that polynomial function about
Basically,
so
this
we
issue.
didn't need the answer, right?
No, but there's one on your math Excel that's going to ask you to. All right. Do we need another intermediate value theorem, or are we good with this?
Ooh,
Okay.
I'm gonna go with synthetic division.
All right, let's review a synthetic division problem. This is something we will be using a lot next week to help us work through some problems, so I want to make sure we know how. So when we're dividing, synthetic division is like a shortcut division that works when what you're dividing by is linear. So what you do is take what you're dividing by, which is x plus 2. What makes x plus 2 equal 0?
Negative. X equals.
Negative 2.
Oh, just.
So we're going to set this up. We put a negative 2 out here.
remember that.
And then we put the coefficients. No x's, just coefficients. Make sure if you're missing a power of x, you put a 0 for that. So if I went from like x squared down to 8, I would have to put a 0 for the x power.
Oh, I think I know what we're
See,
on.
it comes back.
Okay. Is everyone with me so far?
Yeah, I don't like it
Okay. It's a series of basically multiply and add. And that's all we're doing. The first number comes straight down. So my 5 comes down. Then we multiply. So 5 times negative 2.
though. Negative 10. And then you.
And we add negative 6 plus negative 10, negative 16. Multiply. Negative 2 times negative 16,
32.
negative 28 plus 32.
Positive 4.
Okay, multiply 4 times negative 2.
Negative 8. 0.
Let's see. This last number is a remainder. This is our constant. This is x, x squared, it would keep increasing. So my actual answer is 5x squared minus 16x plus 4. My remainder is 0, so I don't have to have that. If I did have a remainder, like if this had been a 10, you'd say plus 10 over what we were originally dividing by, x plus 2. You just leave it in fraction form.
Yeah, I remember that.
But since our remainder is 0, we wouldn't have it here. This is our quotient. What questions do you guys have right there? So, we are going to be focusing on finding factors. And basically, a factor is something that divides.
Please dismiss basketball and cheerleaders at this.
Okay, if something's a factor, that means it divides it evenly. So on this last one, it's a factor because when I divided it, my remainder was 0. It went in evenly. There are two ways of finding if something is a factor. The first one is what we just did. Do the whole synthetic division. See if you get 0. The second one is kind of a shortcut. You can take this number, -2, and plug it into your function. So everybody grab a calculator real quick. Plug that in. So if you did 5 parentheses -2 to the third minus 6 times -2 squared minus 28 times -2 plus 8. What do you get?
0.
0. It gives us the remainder if we just plug that number in. So that's a factor theorem. It tells us if something is a factor, when you plug that in, you get 0. Okay, so we're going to do a couple examples to end today, deciding if things are factors. And really I'm going to show you both ways. We can either work out the division or we can use this shortcut to help us get the answer.
So what's our work gonna be?
I already said.
The board.
Oh, yeah.
No starting it yet. Let me do my examples.
No start. I would never,
Mm-hmm.
ever.
All right, did everybody get down what they wanted from here? One thing I want to stress. I want to make sure you know the difference between a factor and a 0. A factor has x in it. A 0 is just a number. So a factor would be x minus 3. The 0 that matches that, what makes x minus 3 equal 0?
What?
What's the 0 for x minus 3?
-3. Positive 3 because it's plus. Okay.
If I said x plus 4, what would be the
-4.
0? -4. So if I'm asking you, if I'm talking about a factor, that's x plus something or x minus something. If I'm asking about a 0, that's just the number itself. All right, so let's
21
do
questions.
this one.
I'm joking.
Mm-hmm.
It's not actually pulled up. Look.
Okay, I want to know if x minus 1 is a factor of this. So I have two parts here, A and B, so I'm going to do them two different ways. The first way to decide if it's a factor is to do synthetic division. So if x minus 1 is the factor, what's the 0?
1.
So that's what goes in the box. And then you put your coefficients. Okay, so we do our synthetic. 2 comes down.
Which guy?
2 times 1 is 2.
Some people just like woke up one day and was like, this is how you should do math. And we all just agree.
So, my remainder is 0. So is x minus 1 a factor?
Yes.
Yes, the remainder is 0, so it is a factor. All right, the second way if I have a factor of x plus 2, what's the 0? So you could do synthetic, or since all I want to know is does it come out evenly, I could just plug in the negative 2. What do you get?
They got this. I'm confident that they know the
Negative
answer.
27, but I'm confident that's not it. Hold on, let me check.
That's what I got too.
Oh, you did? Okay. Well, I was being pressured,
You
She
tell everyone
didn't
else to
think-
step it up.
and
I didn't know.
I'm
you were
just
gonna
kind
plug
of
it
writing it whenever you were getting ready to press enter.
So, is it a factor?
Yes. No, no.
No.
No,
I didn't
it's not.
make
If your remainder is anything except 0, it's not a factor.
That's true, that's true.
All right, last slide. Same question, but it's going to be phrased slightly different.
No.
So I want to know if the number is a 0. So the last one I said, is this a factor? And what I gave you had an x in it. Here I'm giving you a number and I want to know if it's a 0. So if I give you the 0, that's the number you use. You can do synthetic division or you can just plug the number in.
Oh, well, that's fun.
So if I put in 2,
Fine,
thank
fine.
you.
Thanks, guys. I appreciate it. It's totally not like I do all the work.
Oh, you do not.
I'm just kidding.
I mean, half of my time spent in here is just yelling out answers and hope they're right.
Yeah, yeah.
Yes.
It's 0. So is this a 0? Yes.
Oh, not the
So
fraction.
B, you have a calculator.
No, it's not. It's negative 19.
I got negative 13. Either way, it's not it.
Yeah,
Negative
it's- that's
12
true.
Minus 4, so negative 6. Minus 3. I think you missed the negative on the last one. So, just a sign difference.
That was so rude.
Probably did a
It
positive
wasn't
2
really
or had a minus 3.
I could tell.
Okay. Is this stuff all right?
Mhm.
Yeah.
Okay. So there is a Math Excel assignment open. And
You don't
have time to work.
Ma'am.
Some of them are in behavior.